Today's lesson is Lesson 12, From Ratio Tables to Double Number Line Diagrams. Directions. Solve each one of these problems using a double number line diagram. Let's just make sure, let's box that, because that really is important. That's what you're going to be learning about today, okay? Example 1. Sylvia makes $18 for every 2 hours of babysitting. How much money will she make in 9 hours of babysitting? This is a double number line diagram. See how it has 2 lines, okay? You are going to label each line with a heading about what we're talking about in the word problem. Here we're comparing money to hours. I'm actually going to put hours on top and money on the bottom. And it says for every 2 hours of babysitting, she makes $18, okay? So I'm actually going to put the 2 right about here, and I'll tell you why I didn't put it right about here. 2 hours, $18, okay? This ratio is not a value. It's not in its simplest form. If you've caught on already, these two can both be scaled down. They can both be simplified by dividing both by 2. So I'm just going to write that, and I hope you're writing that on your paper too. Divide by 2, divide by 2. 2 divided by 2, I'm going to draw another line right here, is 1. 18 divided by 2 is 9. Well, let's take a step back and see what that really means. That means for every 1 hour of babysitting, Sylvia is making $9. But the word problem isn't asking us for 1 hour. It's asking us for 9. So now I'm going to continue my double number line diagram until I get 9 hours. 3, 4, 5, 6, 7, 8, 9. This is very much like a ratio table because on the top we just skip counted by ones. So on the bottom we're going to skip count by nines. This is really the additive structure of a ratio table or the additive structure of a double number line diagram. 9, 18, 27, 36, 45, and this is a good time to talk. We're also going to use the multiplicative structure because if you get stuck skip counting down here, you can also realize 1 times 9 is 9. You can use the multiplicative structure too. 2 times 9, 18, so on and so forth. 6 times 9, 54. 7 times 9, 63. 8 times 9, 72. And 9 times 9, 81. So in 9 hours of babysitting, Sylvia is going to make $81, okay? Let's go on to the next example. Jane makes $4.50 an hour at work. She wants to save $29.25 for a trip. How many hours would she need to work to save that much money? Okay, let's look at the 2 things again that we're comparing. We're comparing money to hours. So I'm going to actually again put hours on top and money on the bottom. And I'm really doing this because an hour means 1 hour and 1 is smaller. So that's personally why I just like to put the smaller number on top. It's easier to see the relationship, and it's $4.50. Okay, so she needs $29.25. Okay, so I see the relationship here. 1 times $4.50 gives me $4.50. So I'm going to skip count by 4.50s on the bottom. Okay, $4.50 times 2 is $9. And I'll just show you, if you were to do this problem on your own, bring out your calculator. 4.50 times 3 is $13.50. And Mrs. Creamer, you should do a better job. 2 hours, 3 hours. Let's do 4 hours. 4 hours times 4.50 is $18. Okay, another way you can just do it, if you have that 18 still on your calculator, because this structure is additive as well as multiplicative, you could add 4.50 to 18. You would get $22.50 here. Oh, we're getting close, but not quite there. Okay, let's do 6 hours. $22.50 plus another $4.50. $27. Okay, let's go to 7 hours. Now I'm just going to show you the multiplicative here. 7 hours times $4.50 an hour is $31.50. Now we're over here, but that's okay. It's going to take her 7 full hours to get beyond this point, and she's actually going to make $31.50. Okay, example 3. For every 4 liters of soda, there are 150 grams of sugar. How many grams of sugar are in 11 liters of soda? Okay, so the two things you're comparing are liters and soda. Okay, sorry everybody. It's liters and grams of sugar. Liters has the smaller number of the two, so I'm going to actually put that one on top. Liters and grams of sugar. I'll put G for grams of sugar. It's always good to be more labeled than less. And it's going to be 4. So I'm actually going to do 1, 2, 3, 4. 4 liters of soda is 150 grams of sugar. Okay, so I'm going to scale down. Okay, I'm going to divide both of these by 4 to its very simplest form. And let me show you what happens. I don't want you to get nervous if you have a decimal in your answer down here. 4 divided by 4. 1 liter of soda. Whatever you do to the top of your double number line, you have to do to the bottom. 150 divided by 4 is 37.5 grams of sugar in just 1 liter of soda. That's a lot. Okay, so now we want to go all the way down to 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and we're going to go all the way down, skip counting, by 37.5. Okay, so 37.5 times 2, 75. Okay, this is the additive structure. Let's just keep adding all the way until we get, this is 112.5. Okay, we have 150. So let's do 150 plus 37.5 grams of sugar. It's 187.5 plus 37.5. 225 grams of sugar, plus another 37.5, 262.5, plus another 37.5. Okay, I know that when I add 37.5 to 300, it's going to be 337.5 grams of sugar. If I add another 37.5 to that, oh, Mrs. Kramer. Good thing I didn't write that down. You guys would have caught my mistake. You've got to be really careful when you use calculators that things make sense. And if something doesn't look right, you should always go back and double check it. Okay. I hope some of you are thinking there has to be an easier way. In 11 liters of soda, there's 412.5 grams of sugar. There really is an easier way. Once you scale this down to 1, okay, you can just take 37.5 and multiply it by the number of liters of soda we're looking for. And you will get the same answer instead of skip counting for every single one. The better you get at these, the easier that will become. But good luck on your educanon. We hope you do very well.